Hey, welcome back. This is differential equations 3, and I'm going to do one more example of a differential equation with the separable differential equations. So we have dy dx equals 1 plus y over x squared, where our initial condition is f of 2 equals 0. And we're going to solve this. So again, like before, we have to multiply both sides by dx. So we have dy equals 1 plus y over x squared dx. And we need to get this 1 plus y over to the other side. It's in the numerator, so what would I do to eliminate it from this left to the right side and move it to the left? We'd have to divide both sides by it. So that's how we're going to end up with dy over 1 plus y equal to 1 over x squared dx. And at this level, we are going to now take the antiderivative of both sides. Now, why I like to follow this one up with the one example 3 is because students will think, okay, well, we've just been doing natural log, so it's time to do natural log again. And they'll say, oh, this is the natural log of x squared, the absolute value of x squared plus c. And that is wrong. You can't get into that rhythm. You have to be a critical thinker here. You have to really think about all the things we've talked about and said, oh, okay, 1 over x squared is really just like x to the negative 2. What is the antiderivative of x to the negative 2? It's simply negative 1 over x plus c. Over here, this looks like the one we did before. It is a little u substitution action. I'm going to do it over here in the blue. U is 1 plus y. Du is equal to 1 dy. So I'm really left with 1 over u du. The antiderivative 1 over u, which we know is the natural log. So there's my natural log over there. Alright, so remember, we need to get rid of this natural log. We want to solve for y. So how do I get rid of that natural log? If you remember from the previous example, we raise that as an exponent of e. So now natural log of 1 plus, the absolute value of 1 plus y is the exponent of e. Well, whatever I do to one side of an equation, in order to maintain that equality, I need to do it to the other. So I raise this whole other side as an exponent. So this then becomes the absolute value of 1 plus y. And this becomes, remember that property of x to the a times x to the b equals x to the a plus b. So now we're going to go backwards here. So then it becomes e to the negative 1 over x times e to the c. You remember e is just 2.71828, 182845945, raised to some constant. So it's going to give me another constant. So this will just end up being a c. I'm going to move on to the next screen to look at that. So we have this going on equals e to the negative 1 is e to the c. And then f of 2 equals 0 here. So if you see here, since y is 0, it's not going to be, we're not going to need these absolute value bars. So we're actually going to drop this, and we're going to write this c e to the negative 1 over x like that. And now we're going to plug in 2 for x and y for 0. Or 0 for y, I'm sorry. And then c e to the negative 1 half. We're going to solve for c. So we have to divide both sides by e to the negative 1 half. So this ends up becoming negative 1 over e to the 1 half equals like that. So 1 over e to the negative 1 half equals c. Well, e to the negative 1 half is really just e to the 1 half. If we get rid of that negative exponent, we have our c. So now let's plug it back in and solve for y. So if you look here, we have 1 plus y equals c. So now it's 1 plus y equal to c, which is e to the negative, or e to the 1 half times e to the negative 1 over x. I can subtract this 1 from both sides to isolate y. So y equals, and look what I can do here. We're multiplying like basis. What do we do to the exponents we multiply like basis? Correct, we add them. So it's going to be e to the 1 half minus 1 over x. Subtract that 1 minus 1. So that is the solution to this differential equation. Looks quite a lot different than the ones we solved before in class. But this is how we take it to that next level. So I hope you enjoyed differential equations 3. This is the video. And make sure you watch these as many times as you want to kind of get that idea. Remember a couple things that we talked about, especially this inverse relationship between e and natural log, and this property of exponents that we use here in order to solve. Alright, I hope you've enjoyed this. Johnstone out.